to one of the most fundamental rules in all of physics. Seriously, it's a law that dictates everything from why your morning coffee gets cold to why time itself seems to move in only one direction. It's all wrapped up in a deceptively simple idea called the Clausius Statement. But let's start with something really basic, something you've literally seen every single day. You pour a hot cup of tea, you get distracted, and you come back to find it lukewarm, right? But have you ever seen a cold glass of water on that same table suddenly start boiling all by itself? No way. Why is that? Why is it always a one-way street? Well, the answer is that the universe basically has these invisible traffic signs for energy. And one of the biggest, most important signs says, one way only. Welcome to nature's one-way street. And what's so cool about this is that the explanation for this cosmic mystery isn't some super complicated equation. It's a rule that is incredibly simple, totally elegant, and as far as we know, completely unbreakable. And here it is, the Clausius Statement. It's a huge part of the second law of thermodynamics, and it basically just puts into words what you already know in your gut. Heat does not, on its own, flow from a cold thing to a hot thing. It just doesn't happen. That's not how the game is played. Now, here's how the man himself, Rudolf Clausius, put it. It sounds a little more old-fashioned, a little more formal, but check out that last part. Without some other change occurring at the same time. That little phrase is actually the key to everything. We're going to come back to that. But for now, the absolute easiest way to think about this is to picture a hill. Heat always flows downhill, naturally. It moves from a high temperature to a low temperature, just like a ball rolls down a slope. It doesn't take any effort. It's just what it does. So if heat only ever flows downhill, how is it possible to have things like refrigerators and air conditioners? How do we break the rule? Well, actually, we don't break it. We find a loophole. Okay, let's go back to that super important phrase from Clausius, without some other change. This isn't just some minor detail he threw in. This, right here, is the loophole that allows us to build our modern world. So here's the big reveal. The rule isn't that heat can never go uphill from cold to hot. The rule is that it can't go uphill on its own. But if we're willing to do some work, if we're willing to put in some energy, we can absolutely force it. Think about it like this. The natural flow, hot to cold, is totally spontaneous. It's effortless. But the forced flow, going from cold to hot, that's going to cost you. It requires an external energy source. You have to do work. And your refrigerator is the perfect example of this in action. It's basically a heat-moving machine. First, you plug it in, providing energy so the compressor can do work on a refrigerant. That super chilled refrigerant then grabs the heat from inside your fridge, the cold place, and then the system pumps that heat out into your kitchen, the warm place. It's pushing heat uphill, all because you're paying the energy bill. Okay, so this is way bigger than just keeping your leftovers fresh. The implications of this simple one-way flow of heat are, well, they're cosmic. This rule is directly connected to one of the deepest and most mysterious concepts in all of physics, the arrow of time. So what, right? Why does this really matter? Because it's not just about refrigerators. This one-way street for heat is the very thing that gives time its direction. It's why we experience life as a sequence of events moving from past to future. And this brings us to this huge idea called entropy. You can just think of entropy as a measurement of disorder or randomness. When heat is all concentrated in your coffee cup, the system is relatively ordered. But as that heat spreads out into the room, it becomes more disordered. And because heat always flows this one way, the total disorder, the total entropy of the entire universe is always increasing. And why does that matter? Oh my gosh, it's everything. It's the reason things fall apart, decay, and break down over time. It's why you can scramble an egg, but you can't unscramble it. It is the very reason we can remember the past, a state of lower disorder, but we can't remember the future, which hasn't happened yet. This constant, unstoppable increase in disorder, that is the arrow of time. So we've come completely full circle. That same, simple, obvious rule that explains why your drink cools down is also the profound cosmic law that ensures the movie of the universe only ever plays forward. Which leaves us with one last mind-bending question to chew on. If all the energy in the universe is constantly flowing in one direction, towards a state of maximum disorder and maximum entropy, what happens at the end? Where's all of this going?